So I'm sure this morning. I'm sure you've all seen stormwater wetlands in some of the presentations already, or you've heard about them. But essentially, let's be precise here and talk about constructed stormwater wetlands as distinct from a natural wetland. Essentially, they're designed to capture and treat the stormwater that's coming off urbanised catchments and pass the water through them and filter that water and treat it to remove the pollutants that are coming through it. So some of the distinct things about a stormwater wetland is that those inflow patterns tend to be intermittent. When we get a storm event, we get lots of water in and then they dry out in between. So there's a lot of variation in the water flow coming through, and that means that the water levels go up and down as those events come and go. And the amount of pollutants that they get in them is certainly higher. It's elevated compared to a natural wetland, but it's also not as high as what you might see to a wastewater wetland, which means that some of the things you might do in a wastewater wetland will work, but they might not work quite the same way in a stormwater wetland. So main differences are that intermittency where it's variable flows coming in. So that is more similar to a natural system, but a natural system naturally wouldn't have lots of pollutants coming into it, and that's where it becomes a problem if we've got lots of pollutants coming in. So one of the challenges that we have is that we want to use these for stormwater treatment to take the pollutants out, but then we might also want to get some habitat benefits. Now, natural wetland's great for habitat. A stormwater wetland can provide some habitat, but it's also got there's pollutants coming in, so we've got to be a little bit careful how we mix and match and what our priorities are here. More on that later. So some of the benefits, as we said, obviously, stormwater treatment, that's what we're building it for. We get some evapotranspiration, which helps to get rid of some of our stormwater volumes, especially if we've got a decent sized asset. And then we get some greening and some cooling, same processes. It makes the area look nice. And then we do get a certain amount of biodiversity. You'll certainly find more birds around one of our stormwater treatment wetlands than you'll find even just around some of our drier parks and that sort of thing. In terms of how they do it, essentially they rely on sedimentation, which is just the sediment settling out through the water. Filtration as water passes through thousands and thousands of plants, and then adhesion, so basically the pollutants get stuck to the biofilms that are growing on the plants, and then they get taken up into those, then the biofilms die and they drop off and they get bound up in the sediment, and then the plants take up the nutrients. So there's a whole range of different processes going on. There's nitrification processes and denitrification processes for the people that have been doing chemistry occurring, and they all occur at different parts of the wetland. And essentially the idea is to gradually capture those nutrients, capture those pollutants and bind them up in the plants and in the sediments that lie within the wetland. So as you've probably gathered, from what I've been saying, plants are really important for a wetland's function. It's what defines a wetland as distinct from just a large open water pond, and it's how we get all those additional processes, not just sediment settling out, but it's also how we get long-term pollutant removal. Because what happens in a pond is that the pollutants are captured, but then there's nothing to stop those pollutants being stirred up by the wind and the sediment resuspended and then washed out again, or for those nutrients to eventually lead to algal bloom conditions in that pond. Whereas if we've got lots of plants in the wetland, that helps to actually use up and take up the nutrients. So that's some of those processes as they apply to different pollutants. So nitrogen, I mentioned we've got that nitrification, denitrification. Your organic ones, you've got different processes going on. And then your organic material, so we might refer to BOD load, we've got that breaking down biologically, we've got the sedimentation occurring. So there's all those different processes occurring for the different pollutants. Importantly, they will take up the heavy metals, and the plants will use only very small quantities of that, but they will use some of those heavy metals. So we do see them being stabilised and taken up and used as well. Things like pathogens will just naturally die off, but keep in mind some things are going to die, some things might actually breed, so it's not a black and white sort of outcome there. As sort of foreshadowed in earlier comments, we use these really widely in Melbourne, Victoria. So we have an urban development and we'll direct that water into a stormwater treatment wetland to do the treatment so that we can meet our objectives. And it's worth noting that whilst our objectives are couched in terms of get these reductions of suspended solids and nitrogen, implicitly we're using those pollutants as indicators to also say, well, we actually want to remove heavy metals and other stuff from the water, but these are easy to measure and report on, so we'll use those as metrics, as surrogates essentially, but that's then gives us an indication that if we got those ones out, we also get all the other pollutants out effectively too. So just finish our break in the food. So different components. We've got a inlet zone or a sediment pond at the start of the wetland, and the purpose of that is to capture sediment. So we always want to try and capture the heavier, the larger material up front. There might also be, it's not shown here, but there might be what we call a gross pollutant trap in front of that, and its function is just to capture all the litter and the rubbish that's coming down, washing through the catchment. Then we catch the sediment, and we want to capture most of the coarse sediment within the inlet zone. Water then flows through the wetland, and typically we'll have deep pools and then we'll have shallow areas within that wetland so that there's a diversity of different environments so that we can support the plants, but also there's opportunity for sedimentation to occur, and there's somewhere where the fish and other creatures can live. So this will fill up when we have a storm event, and then it will drain down slowly. So this is a better picture of the inlet pond or sediment pond. So we have an inlet coming in, bringing the water in. We'll have an outlet, which will sometimes be a pit and a pipe connecting to the wetland. Sometimes this will just be a weir, so it might be what we call a submerged weir, so it sits below the water surface, but it allows the water to move from one pond to the other once it gets above a certain level. And then we usually have an overflow weir on this inlet pond. And the purpose of this is so that when we have a storm event and the sediment pond fills up with water and the wetland fills up with water and it reaches a point where it can't hold any more water above its design upper limit, which we call the top of the extended detention depth, what will happen is that water will back water back through the system and it will spill over that weir and it will divert around it. And then any additional water coming into this system can come in the inlet and then be diverted through that bypass. And what that recognises is that we can only design our wetland to handle a certain flow and a certain amount of water passing through it, because we need to allow time for the water to be held in the system and be treated before it passes out. If we let the water through too quickly, we won't get effective treatment. Also, if we let the velocities get too high, that might damage the system. So the idea of the bypass is that it's then directing those really high flows around the system. Meanwhile, sediment accumulates and settles out in the sediment pond. And we have what we call a sediment accumulation zone. So the bottom part of that sediment pond, the sediment fills up and fills up that system. And generally we design it so that the top half a metre or so, 500 mil, is essentially clear or clean water. And then everything below that is allowed to be filled up with sediment. And once the sediment gets to that level, we know that we need to come in and need to scrape it out and clean out all the sediment from that system. Because if we don't, eventually it will fill up this remaining bit of water, and then the sediment will get washed into the wetland. And once it gets into the wetland, we've got plants in the wetland, it's much harder to remove that sediment. So what we want is for this to act as a sacrificial zone so that we can come and remove that sediment on a regular basis. And as you guys will know from your experience as engineers, whatever the first pool is we put on these systems, that will always act as the sediment pond, even if we're not designing it as that, because the sediment will settle out of the water once we slow it down.
Excuse me. What is TED means?
TED. So we have a thing in Australia that we call extended detention depth in association with wetlands, and the extended detention depth extends from the normal water level, or NWL, up to the TED, which is the top of the extended detention depth.
extension deck.
So, so I'll try and put that in plain English. Essentially, the normal water level is the water level that the wetland will be at if you go and look at it on any normal day. That's what it will drain down to, and it won't drain down below that point. So that's the level that the outlet will let the system drain down to. The top of extended detention depth is the level that it will fill up to while there's a storm event happening, the maximum level that it will get to before it goes into bypass or overflow. So this weir here will be set at the level of top of extended detention depth. So once you reach that level, water will then start to backwater through the system and spill over that weir. So probably your two most important levels in a wetland to know are your normal water level when it starts to overflow or starts to flow through the outlet, and then that top of extended detention where it will start to overflow back through the system. And then below normal water level, we'll have what we call permanent pool storage. So that's water that can't escape from the wetland via an outlet or an overflow, but it can evaporate from the system and it can infiltrate into the ground. So we call that permanent pool, but you might also think of it as dead storage, is probably the more familiar term. So the idea is that this macrophyte zone, the water moves slowly through it, and it's got a range of different depths, and we've got plants and we've got microorganisms and algae growing in these areas, and they help to remove the pollutants. As an indication, we design these systems so that it holds the water for on average at least 3 days, so that it's got enough time to treat the water before it comes out. So the longer we hold the water, the more treatment we get, so the further it will treat the water. But if we hold the water too long, what it means is that we'll still be treating that water when the next storm event happens, and then it will flush that water out through the system and bring more water in, and we'll get more overflow. So the time is a balance between let's hold it for 2 weeks because then we'll get really good treatment, and let's get the water through the system and then drain the system so that it's ready to take the next storm and the next lot of water that's coming into it. So we're trying to get a balance between those. For those of you that have worked in wastewater treatment, you'll know that 3 days is already pretty short. You probably design a wastewater treatment plant for 5 days or 7 days or possibly longer. But these systems will be subject to quite frequent storms coming through and a certain amount of loading. So the other thinking behind that is that it rains on average about every 3 days in Melbourne. So if we have 3 days of residence time holding it, that means on balance it should be reasonably drained out and available for the next storm event fairly frequently. Now that logic will not work in Thailand, and in Bangkok it won't hold up because you've got a wet season and you've got a dry season, and it drains on average how many days a month in a wet season? Anyone got a rough idea? How many days of rain would you get in the middle of the wet season?
ฝน3 เดือน
ของชีวิตช่วงหน้าฝนประเทศไทยฝนตก
4 เดือน
like 5 months of rain during the 6-month season.
Yeah. It's really wet. It's almost every day it rains, doesn't it? So, yeah. So
it rains every day.
Pretty much every day it rains, and then dry season's the opposite of hardly rains at all. So this, you may have to adjust that in Thailand, and in fact we're having debates about that in Victoria at the moment because we've held to that rule for quite a long time, and we do need to hold it for long enough to get treatment. But if you go to Queensland, which has got a climate that's more analogous to Thailand, they've got more tropical weather, they actually aim for 48 hours for treatment time or detention time. So you may also find that a shorter time works better for you in Thailand. And that's really getting a balance between holding it long enough to get good treatment, but also getting the water through the system. JB, you want to...
Great, thank you, Dale. This is really cool because they are the designers, they are the real designers within R&D, and I'm glad asking these questions because when we talk about multifunctional, it also means that within this year, right, it is a multifunctional across the season, right? The simple way we can break this down is that think about it like a dry season, wet season. Right? So they will just show you how to design a wetland with normal water level. Right? Let's say the normal water level is here, and this could be your, this could be your dry season, wet season. Think about this. Why I say this is that, well, in the recent design, right, you can create two versions of normal water level. Right? Just before you go into the dry season, you increase your normal water level to that point, so it can offset the evaporative loss across the 5 months. Right? That's really important because tomorrow we're going to on Wednesday, the first project I was going to show you is that we have a completely dry sedimentation basin because that was 10 years old design. Didn't think about this, right? And how do we make sure the wetland can have two normal water levels? Is by designing a weir that can adjust the height by either mechanical or remote sensing or remote control with the actuator. So with the IoT, you can raise the weir up and down based on seasonality. So that's exactly what they're talking about. Next generation wetland, you will design at least two normal water levels. Depends on the seasonality. Great. Thank you.
And that's where the research is heading. It's a bit more sophisticated with control on those. So I probably should have flashed this one before. So that's your normal water level. So it's holding the water to that level. So I should point at the right one. And then it's allowing it to fill up to extended detention depth and drain down. And you've got, as we said, you've got these deep pools. Usually you've got a deep pool at the start and the end of the wetland. And that's useful because of what it does is it helps get the flow evenly distributed across that area because we want the water to spread out and go through the whole wetland. We don't want it to just create a channel through the middle. So having a deep pool and then a shallow section helps to force that water to spread out across the wetland. And then we usually do one at the end. So the water will come in, it's right in that pond, it will flow into the wetland, fill up the deep pool, and then it will pass through the wetland and out the outlet. So under low flow conditions, that's how it will be operating. It will fill up, and then once that extended detention depth is full, it will then force back water, and then it will overflow over this overflow and around the wetland. And this is really important in protecting this area from higher flows and higher velocities. So this is an example. So these are your wetland cells or pools here. This is a newly constructed one, that's why it's dry. So these are your different wetland cells. The inlet or your said pond is up here, so that will then have a pipe under here. And then this is the high flow bypass channel here. Most wetlands, it's not that clear cut and obvious what's going on, but this one's got a very nice, very clearly defined high flow bypass channel. I think the next slide has another picture, and this is what it looks like in a storm event. So you can now see the wetland pools have got water in them, the seed pond's full, it's fully engaged, and then the water is flowing down the high flow bypass. So this is how we want these systems to function and operate.
How would they operate in a full flood situation? So I guess I'm thinking here, particularly Brisbane, where we do have those really intense rainfalls.
Yeah.
And that would fill up fairly quickly, so about 20-hour period.
Yeah.
What happens then?
What happens? Yeah. So Helen's asking the question, what happens if we get a really big flood and it's bigger than this bypass system can handle? What will happen to this? So not always, but very often, we will design our detention basins or retarding basins, which are flood storage detention basins in Victoria, and we will design the wetland so it sits in the floor of the retarding basin. So what it means is that if we do that kind of design, what it would mean for this is that in a very large flood event, this whole area would fill up with water and the whole system would inundate and be filled with water. Now, that's okay for a wetland as long as it drains in a reasonable period of time. So if this whole system went under, and it went under for 10 hours or something, but that retarding basin then drained out and drew down the retarding basin, and then the wetland underneath it would continue to function as designed. That would be okay, essentially, and that's how we design a lot of these systems to operate. I'm trying to remember. When you see the Harcrest retarding basin, you'll see a system that has that kind of operation. Not all systems are designed to operate that way though. Some systems will be designed so that the wetland will take the lower flows and the bypass channel will actually take the full 100-year flow, so all of the water will go out and around the wetland when you have those very large storm events. So, JB, are you going to Huntingdale or
Harcrest, we're doing Harcrest on Thursday.
Yeah, okay, yeah. I'm just trying to think which ones. Yeah, there's a couple of others near Monash where you can see a very large bypass channel where the water will divert around it.
Yeah. So Troops Creek's on Wednesday.
Oh yeah,
That's a very clear highway bypass.
You'll see that one. Yeah. Okay. So let's talk about some design considerations. So obviously, first thing to note, wetlands take up lots of space. In Melbourne, we design them to be about 3% of their catchment area. So if you've got 100 hectares, you'll need about 3 hectares of wetland. That's kind of a rough rule of thumb. If you want to build a wetland in Queensland, it'll probably need to be about 6 or 7% of its catchment. So what happens in Queensland is people often build biofilters instead because that's too big and they're not willing to give up that much land. So they'll do a biofilter because they can get that down to maybe 1 or 2% of their catchment and then get away with it, and that sort of works. That said, wetlands are a good alternative because there's a few tricks in designing them and they're a bit challenging, but they're more robust and they're harder to get wrong than a biofilter, and they're more likely to survive some adverse conditions than a biofilter will. So we've got our sediment pond, we've got our planted area, our macrophyte zone through here, and in Melbourne we say that 80% of that has to have plants in it, and it's got to be fairly shallow so that the plants will survive. The remaining 20% can be the deep pools. We need to make sure that there's access so that we can physically get to the sediment pond and we can take the sediment out of it. So you've either got to be able to drive an excavator up next to it, reach over it with the excavator, or you've got to be able to drive into it with a bobcat and you've got a ramp running down into it. We then often have a dewatering area where we take that sediment, we dump it so that we can then let that dry out until it's easier to handle, and then we take away the dry sediment. It's cheaper to dispose of. Bypass we've talked about, and then the other thing to keep in mind is that a wetland has to be low enough in the landscape that the drains can come into it and drain the water into it, and then it can drain out the other side, which means that they're always going to be sitting pretty low in the landscape. So you're always looking for those low-lying areas where it's going to naturally flood or naturally drain to put it in, and then you're often going to have to excavate down from the natural surface levels down to that at a minimum for the depth of your drainage. So you'll always need some batters around the wetlands, and this diagram doesn't really do it justice because it's got these tiny little batters here. They're a bit deceptive, but the reality is that sometimes the batters can take up more space than the wetland itself because you've got to get down 1 metre or 2 metres or 3 metres from the ground around it and get down to the bottom of the wetland. So keep in mind that when we design these things, you've got a water surface area, but you then need to allow some extra footprint for the batters. So don't get caught out when you're designing that you need to allow more space than you think. So another aspect we want to think about when we're designing, you'll notice, if I come back, you'll notice this sort of long skinny shape and sort of winding around. We haven't just got a round pond, but it's long and skinny. The reason for that is that we want to make sure the water is evenly distributed as it moves through the system. So what we want is what we call good hydraulic effectiveness from the system. So we want the water to be evenly distributed and to pass through all parts of the wetland, not have any dead spots or short-circuiting occurring where the water isn't passing through some of those areas. Because if the water isn't passing through an area, essentially we've wasted money building that area, we're not getting any value out of it. So some different options. One is you can spread the water really evenly at the start, put wide weir or something to make it spread evenly when it first comes into the wetland. You can put some baffles in to get that sort of serpentine shape that we're looking at. You can just make it straight out, really long and skinny, but that's not the most efficient shape to construct sometimes. Or you can put something across it to try and spread the water. So there's different ways of setting this up to try and get better hydraulic efficiency out of it. Essentially what we're trying to avoid is this kind of design where we're not using all of the space within the system effectively. So, does that make sense? Engineers here, I'm sure you all get that. Tell me if you don't know. So shape, we want that even flow distribution. So this is the one I had up before, I think. So an example, we've got this long sort of skinny serpentine shape to try and make sure that the water is evenly distributing across the whole system. Again, we've got the varying widths and depths also to try and get that even flow distribution and provide opportunities for different plants to grow. So one of the challenges of having a long and skinny system is that it tends to translate into higher flow velocities as water comes through the system. We need to think about two things here. One is resuspension of sediment, and the other one is the plants themselves and the biofilms that grow on the plants. So ideally we want to keep the velocity during sort of typical operation of the system to quite low levels so that it's not basically stripping off the biofilms that are growing on the plants and washing them away so that they can't do their job and be removing the pollutants. And look, if we get a 1 in 10 year storm and it strips them off, so be it. Let's accept that the wetland's not going to be perfect, it's not going to be working fully functional all the time. So if it happens in a big storm event, that's okay. What we don't want is for them to be getting stripped off and washed away every 2 weeks because they won't have time to grow back and recover. It might take a few weeks to get back to their full potential again. So we have some requirements that the velocity should be kept below 0.05 metres per second, so it's quite low, it's really low, and that's for a regular storm event. So the design event we're using in Victoria for this is what we call a 1 in 3 month flow, or a 4 exceedances a year. So basically we're saying that you can have a storm event that will wash off your biofilms 4 times a year is okay, any more than that's no good. So you've got to design so that your velocities aren't exceeding that. And as a simple check of velocity, you can just look at your flow rate through your outlet and then compare that with your cross-sectional area through essentially the smallest cross-section through your wetland as you're passing through it and say, is the velocity less than this? Similarly, we do a similar check. Let's see if I can get the slide for it. No, I didn't. We can do a similar check for higher velocities and less frequent events, and that's to check that we're not resuspending our sediment during those higher flow events. So we've got a couple of different velocity checks that we can do to try and make sure we're looking after our wetland. Interestingly, these actually can become quite challenging to meet once you've got shallower wetlands and you've got all the other constraints that come into play. So, good to have some engineering and some numbers at last. Okay. Actually, I'll just pause there. Is there any other questions around design, around shape and velocities and bypasses? Is that all making sense so far? Yep. Okay. I'll move on to another design consideration that's a bit different. That is drowning. Because if we're building any kind of urban waterway in an urban area, we need to think about what is the risk of drowning in this particular asset and how do we minimise that risk? How do we prevent or avoid that being a risk in this particular asset? Now, fortunately, people usually aren't going to choose to go and swim in our wetlands or in our canals or our ponds, so we don't have to worry so much about that. It's more about people falling in there or accidentally going in there that didn't intend to that we have to think about. So, 300 and something people drowned in waterways in Australia last year, so it's not something we can ignore. It is significant. So we need to ask some questions. Who is most at risk of drowning? How do we minimise drowning risks for everybody? How do we ensure that there's safe access? Because we actually want people to come up to the wetland. We want people to be able to come right up to it and look at it and see it. You know, we could say we're going to build a retarding basin, we're going to put a wetland in it, we're going to put a really high fence around it, we're going to have really steep barriers, and we're just going to put it at the back of the development. No one goes there, no one sees that. We could do that. But then that land would be useless. It wouldn't serve any other purpose except flood mitigation and maybe a bit of treatment. But these days we're trying to put our wetlands at the front of the development so everyone can see it and everyone can walk down and touch it. But we need to strike that balance between people being able to see it and get near it safely, but not fall in it and drown. So we need to think about who we need to think about in terms of the drowning, because it's not just you or me. Okay, we're young and fit. If one of us fell in, no worries, we could probably get ourselves out of a wetland if we had to. If we're doing some water quality sampling, we tripped over, we'd probably be okay. These are some of the stats for Australia for drowning. So gives us an idea, a flavour of who is most at risk. So what we see is that elderly people are at risk, 33%. So obviously people that are a bit older, more likely to have a mishap. Interestingly, in Australia, particular context, but a high percentage of the people that drown are actually born overseas. And sadly, there was someone from the Vietnamese community that drowned just a few weeks ago, one of our beaches. And interestingly, a very high percentage are actually men. There's some ads going around at the moment, and it's called Unsinkable Man or something like that, because the people at the highest risk of drowning are middle-aged and older men, just like me, who think they know how to swim and think they're going to be fine. So there's probably two people at risk: the people that can't swim and probably should stay out of the water, and the people that can swim and think they're good enough and can't swim as well as they think. So they're probably kind of, in Australia at least, two of the main groups we've got to think about. One is, who are the people from overseas, who are the people with families, with children, with elderly, and then the second one is the stupid men that think that they know better and know how to swim. So they're the two demographics we're working to. So we need to think about it throughout the process. When we start the concept, first we've got to ask the question, is this a sensible spot to put a wetland? Should we actually be building an open water body here? All the way through to the detailed design where we're designing weirs and we're designing boardwalks and bits and bobs. That's where it really comes down to, well, is this a safe design or not? But I would suggest that we should also step back and think, what's the community that's going to live around this wetland and what are the demographics look like? If it's a greenfield development, that's not easy because we don't know the people that are living there because they haven't moved in yet, although we can probably guess who they're going to be. What's near it? What would be expected? If we're putting a wetland in a floodplain and it's right next to a waterway, we might go, hey, people need to know not to step into the creek. So if we put the wetland here, they're going to be able to figure out stepping in the creek's a dumb idea, stepping in the wetland's not a good idea, so let's just stay out of it. You can be reasonably safe. But if there's no water for miles, you might think a bit differently about it. So I'll give you a bit of an example. This is a design that we did, and this is in Kings Park in Melbourne's West. So we've got a park here, and they said this park is really dry, it's really boring, it's literally a dust bowl in summer. What can we do to make this place more interesting? There's a drain that runs right through it, and we said, well, hey, we could probably get the water from this drain into a pond or a wetland, make this place look a bit nicer, green it up, get some amenity for the people in the area. There's no water for some distance around here, so we'll think about that. We looked at the demographics of this suburb, and I looked these up again the other day. So 40% of the people are born in Australia. So where's everybody else born? Not here. Okay. So 60% of the people in the suburb are born somewhere other than Australia. Look at their ancestry, and we see most of them are Vietnamese, as it turns out. I don't know if that's right. It says 10% have ancestry of Australian. Oh, we've got 8% English, so okay. So there's a lot of people from overseas here, which, if you remember the slide I showed you before, are a high risk group for drowning in Australia. Now, Thailand, obviously, this is going to be different because you've got a different culture, different contexts. So you probably have different demographic groups that are at risk. So you have to ask yourself, who are the most at risk in Bangkok? Because it's probably going to look completely different to here. Probably worth asking, who can swim in the room? Who knows how to swim? Okay, that's quite a few. It's about half, maybe half. So, talking about this cultural difference, swimming is one thing that Australians take really seriously, as you'll have seen if you've watched us at the Olympics or something. So most Australians, and particularly white Australians like me, get taught how to swim from a young age, and it's really drilled into us because we're always at the beach in summer and we're going down to the lake and we're doing things. So it's really important to know how to swim. My daughter, we went on a holiday to Thailand and Asia a couple of years ago. I had to save her from drowning 4 times on that one trip. And if I wasn't there, she would have drowned each of those times. There's one, someone else would have saved her. The other 3, it was up to me. So it's really important that you know how to swim, and you can save someone if you're an Australian because there's always water around and people are always going in the water. So that's really drilled into us from a young age, but that's not the same for all cultures and all people. And even within Australia, you'll find that there's lots of people that don't know how to swim. So we need to think about that. So this is now officially, based on what we've just looked at here, this is now a high-risk site, much more than an average park. We already know that. So we need to be thinking about who lives around here. So, all right, they come from all different cultures, they come from different languages. So we can put a sign up saying don't go in the water. Can't assume they're going to understand that sign. We know that there's statistically higher risk, and we know that there's no water around nearby. We also know that there happens to be a playground right next to where we want to put the wetland. So we've got all sorts of problems at this site. Probably should have been asking the question at this point, should we put a wetland in this park? The council there were pushing us to put an open water pond, which we ended up proposing, but we had an urban designer from the very same council come through our consultation at the park, and the first thing he said to me was, we shouldn't put an open water pond here, it's right next to the playground. We should put it somewhere else or get rid of it altogether. He's probably right.
Does it ever happen that the playground comes later?
Yes, the playground is that first.
Question?
What? Did it happen that the playground comes later, like after you install the wetland?
What happened to the outcomes with that one?
So was the playground already there?
Was it already there? It's so there's a small playground already there, but it's going to be refurbished as part of the proposed works to the park.
Yes, but what if you finish the wetland and then somebody build playground later?
Right next to it.
Then
Well,
the same risk.
Yeah, the same risk would be there. Yeah, I guess you can't help that. You built the playground based on the risks that you're aware of at the time. If you're building a playground next to a wetland, you probably should consider the risks and think about whether you need a fence. So I'll give another example, not that site, but another one. They built a biofilter in my local park, and it's probably less than 10 metres from the playground across the path, and there's a path that runs around right next to it. Now, when they originally built that biofilter, they put a temporary fence around it, but no permanent fencing. Now, that biofilter has a drop from about where my hand is to the ground, straight vertical drop off the rocks, plants behind it, you can't see it, straight down. And then if it's flooding, there's water there. I looked at that and said, surely they're putting a fence there. They come back about 3 months later and they build a fence. Obviously, sanity prevailed, and someone said you can't build that without a fence that close to a playground. It doesn't make sense. So, you've got to think about what's there. But that said, sometimes you've got existing things. Footscray Park has existing ponds. They're heritage listed, and there's a playground right next to it. Because of the heritage, we're not allowed to touch the ponds. We can't change the design. We're not allowed to modify anything with them. But 2 children drowned in those ponds in 2 years. So after that, they said we can't have a playground here and ponds here. It just is not safe. So they've actually demolished the playground and taken the whole thing away, and they're going to rebuild it somewhere else, further away from the ponds, because it's not a good idea to put the 2 side by side. So, yeah. So, whoops, I'm just looking at my slides. So we need to think about safety. It's really important when we're designing these systems that this is front of mind, and that we're also thinking about our communities and who are the different people that might be affected. And we've also got to think about what's normal. Safety in Thailand you have different norms and different things that are accepted. You've got deep canals and things like that. So you've got to think about what people are used to accepting. Here you can go and walk down the waterway and there's no fences on the waterway to stop you falling in. Look out. So you've got to think about what's suitable in that context and what people are used to as well. But we've got to be talking to our communities. But in terms of engineering design, there's things we can do as well. So our guidelines for wetlands in Melbourne say you must have a slope that is no more than 1 in 8 for a certain distance on each side of the wetland as people are coming down into it. You've got to have batter slopes of 1 to 5 above that. And only then can you have a deep pool. Or if you're not meeting this criteria, you've got to have something else around it to prevent people having access to come in. So you've either got to put a fence, or our other favourite thing is just to plant some really nice tall spiky plants that no one wants to walk into. So that can also work really well as a barrier. And sometimes we do both. We put the spiky plants in and then we put the fence up as well, just to be doubly sure. One of my colleagues probably put this the best. He said, whatever we're designing here, we want it to be a safe batter. So whether it's a steep batter with barriers that are stopping people getting in, or whether it's a flatter batter, whatever we're doing, we've got to try and make sure that it's a safe batter and that we're providing safe access down to the water. And when people walk down to the water, it's predictable. So ideally, the slope once they get to the water should stay the same for a certain distance. So as they walk into the water, it's going down at the same amount. They're getting feedback and a signal saying water's getting deeper, you should stop walking at this point. But we don't want it to go completely flat and then go off a cliff and a drop, because then they're not expecting that. They're going to take a step and suddenly fall in. So we want it to give them continual feedback that tells them you're now in water, probably should think about this. Once we get into the water, we do have some compromises, however, that say once you get to a certain point, you can have a quite steep slope of 3 to 1, and that's to balance that safety with the practical reality that you've only got so much footprint to put this wetland into, and we've got to get it down to a certain depth so that the system's actually viable. So we've got to balance. We want safety, but we've also got to actually build a system that functions and works. So there's a bit of a trade-off there. And the developers are continually coming to us with designs that have, rock weirs and retaining walls and all sorts of things to try and cut short this process and reduce the amount of land they need for the wetland and try and cut that down. But we've then got to balance that with how do we make sure that that's actually safe for people. So I've kind of said most of these, but at minimum we need safe slopes on accessible edges. We need fencing or impenetrable plantings, so plants people can't walk through where we've got deeper water areas. Any maintenance access is important to make sure that we've actually got a gate or a fence, so people can't just walk straight down the ramp into the water too easily. We want to make sure that kids aren't jumping on the outlet weir or the outlet pit and climbing over things if we can avoid it, or that we're designing them to handle that alternately. And usually we try and have some offset to nearby properties. Honestly, 15 metres is really not much of a distance to be from the nearest house, but that's the requirement in the current Melbourne Water Guidelines. So, come back. Any questions on safety and some of those considerations? Yeah.
Oh, can you share a bit more about maintenance cost, or I don't know, do you have to like replant some plant, or do you have any problem with water hyacinth, maybe, is that what you call? Yeah.
Yeah, so water hyacinth, so floating plants and weeds. So there's a couple of things you'll have to think about for a wetland. Just come back. Slides. Yeah. So your sediment pond, you will need to clean that out on a reasonably regular basis, and that's probably the largest part of your costs for maintaining a sediment basin. Certainly Melbourne Water's experience has been is that it's expensive to clean out the sediment ponds and take away the sediment. Now, one of the challenges here is that we want to design the sediment pond so it's big enough that it captures coarse sediment coming in, and so that we don't have to clean it out too frequently, because if it's too small, we're going to be there every 2 weeks cleaning out the sediment and getting a few teaspoons. So it's got to be big enough that minimise that frequency of cleaning, But ideally we want it sized such that it's big enough to capture coarse sediment like sand and stuff, but it lets the really fine sediment like clay pass through into the wetland, and with it most of the heavy metals. So we want this to capture the cleaner sediment so that we can just scoop that out and take it away. What happens is if we design this too large, we end up with heavy metals in that sediment, and then the cost of disposing of that is much higher. I'm not sure about Thailand, but to take away a cubic metre of clean sediment might cost us $100 or $200 a cubic metre in Australia. To get rid of a cubic metre of contaminated sediment that's full of heavy metals and other things might cost us $400 or $500 a cubic metre, up to even $1,000 a cubic metre if it's really bad. So it's much more expensive if we get those heavy metals in. So one of our challenges is to design this in that just right sizing so we only get the clean sediment within it. And essentially what we're saying is let the heavy metals go into the wetland because we're hardly ever going to reset and clean that out, so it won't be such a problem to be disposing of that volume of material with the heavy metals. So that's your main cost. Coming to your macrophyte zone, and I'll see if I've got a good image. Coming to your macrophyte zone, the intention is that this should stay well vegetated and reasonably stable and stay there for a long period of time. We say that a wetland's got a lifespan of about 20 or 25 years, so we expect after that we might have to come in and reset and renew this and clean out some of the sediment and replant. In practice, what we find is that some wetlands will probably last forever, and the longer they go, the more plants they get, the more well established, the better they are. Some wetlands within a few years we've got problems with them, especially if they've got too much water coming in, they didn't get the design quite right, they were a bit too aggressive in how small they were trying to make it. And we see wetlands where they're only 3 or 5 years old, we need to come in and replant the plants. So you'll have a couple of things there. One is that you might have birds eating the plants, especially when they're just getting established, and that might mean that they never got established in the first place because the birds just come in and munch them, or you've got ducks everywhere and they're all eating them. The other one is that the water level might be too high, and this is by far the biggest problem we've had in Melbourne with wetlands, is that we design the wetland a bit small and then the water levels are too high too often and more than what we'd like them to be, and basically they just drown the plants. The plants can't hang on for 3 weeks with water levels sitting at the top of extended detention and staying really high, and so they die off. So if that happens, then you've got to lower the water level in the wetland, and then you've got to come in and replant it, and that can be quite expensive if you have to do it. So we try to avoid doing that more frequently than we absolutely have to, but if you do, you could easily be up for quite a bit of money to replant a whole wetland.
So we shouldn't build a wetland on some area that are flooding every year, right?
You can put it in an area that floods as long as it doesn't stay flooded for weeks and weeks on end. So if it floods but it then recedes relatively quickly, that's okay. I can see people going, the whole wet season, that's flooded. It's flooded for months.
It's called a wet season.
Yeah. Basically, you want to design it so that the water levels are within tolerable levels for the plants if they're going to be there for long periods of time. So you don't want the water to be sitting half a metre or a metre above the plants for weeks and weeks on end, because that's going to kill the plants. And that quite possibly means there's some areas in Bangkok or Thailand where you can't really build a wetland because the water levels are going to be too high for way too long. That said, there'll also be areas where you get a really bad flood once every 2 or 3 years, and it's there for a few days, but it then does actually drain out and move away. So I'm sure you've got some of those examples as well. So, thank you. Any thoughts or comments on your experience with some of your... I'm sure this is going to be a huge challenge for the wetland design, getting these balances right.
How about the problem, maybe not the problem, the mosquito and animal kind of thing? Do you have to use DDT, or I don't know, what are you doing?
So you'll notice that this has a bit of grade on it all the way through. What we try to do is make sure with the wetlands that there's no depressions that will just hold water for long periods of time, but that the water will all drain down into the deeper pools. And then what we try to make sure is that there's fish in them, and they can actually be native fish or any sorts of fish. People get excited about mosquito fish because they eat mosquito larvae. The reality is that any fish will eat mosquito larvae if it's there. So as long as you've got some fish in there or other creatures, then they'll come and eat the mosquito larvae. So what we don't want is shallow depressions that get trapped at different locations away from those deep pools, because that's where you'll get the mosquitoes breeding. So that will minimise the issues with mosquitoes. It won't eliminate them. If there's water, there's going to be mosquitoes. They'll find somewhere in the bank, so you'll get them around. We don't, as a general practice, use spraying pesticides on our wetlands in Australia. Generally they're not sprayed. There might be some occasional examples. Generally we don't. I'm aware that in tropical areas you've got a much more substantial problem with mosquitoes than we do also, however. But a lot of it comes down to good design, to design out the habitat so that you're not creating habitat for them. But it does mean you need to come back and actively look after your wetlands, because otherwise things can move around and shift over time, and that can allow habitat to form.
It's the same as if you had just a concrete drain. You would need to make sure that there wasn't pooled water where you could also have mosquitoes. It's the same thing.
And in urban environments, it's often a problem because any little bit of rubbish sitting in the street can hold a bit of water and become mosquito habitat. So often there's lots of little tiny opportunities for them. But certainly if you're designing the wetlands and you're doing it in Thailand, you're going to get questions about mosquitoes. So you need to explain that you're designing it so there's no shallow pools that are going to hold stagnant water that the mosquitoes can establish in. It all drains to these deep pools, and these should be large enough to provide habitat for other creatures that will suppress the mosquitoes. It won't 100% eliminate them, but it will keep them to a minimum. And you will get other creatures. You'll get snakes around the wetlands. You'll get rodents. You'll get foxes, or you won't get foxes probably, but we do. So you will get other creatures living around them. They are providing habitat. As long as they're not excessively damaging the wetland, that's okay. We want some creatures to be able to live within this environment. So coming back to this question about water depths, it's a fairly key thing in terms of wetland design. So Melbourne Water have noticed that we actually have problems here, that we let our wetlands get too deep too often, and then the plants are dying off. And we've actually tightened up our regulations about how deep you can make a wetland and how quickly they need to drain out to make sure we're not getting those problems. We've tightened those up in the last few years to try and improve that. So if you think about, wetting and drying spells, you might have, the wetland in red here, fills up, draws down, fills up, draws down, fills up, draws down, and it's draining out fairly quickly most of the time. And then if we look at the other one, the blue wetland, what we see is that this wetland is not draining out nearly as quickly. It's got a much slower drawdown curve here with the water level. This is water level here versus time. It takes much longer for it to dry out. And then we see during this wet period here, we see it's holding water for long periods of time, and then it's drying down and it's holding water, and it's essentially holding water for most of that time for, it's the better part of a month here, and then it's drying down. And that's where we might start to see some challenges with the plants being able to handle, in this case, 1/2 metre of water sitting above them for a long period. So you'll need to do this kind of analysis with your wet season and your dry season to look at what the water levels are going to be in your wetlands and whether they can sustain the plants with the wet and dry spells that you've got. You'll probably have a fair bit of work trying to get the balance right and get the levels of your wetland right so that the plants will be shallow enough that they can grow through. The other side of that is to pick taller plants, obviously, that can grow taller and then they can handle more depth of inundation, but you've got to grow them to that height to be able to handle it. So that can take some time. So this is another example of a wetland where the water levels are, this is basically a measure of what is the height of the water level. 0 is the normal water level, so that's what it's designed to naturally return to. And then this is the percentage of time that it's exceeding any given depth. So we call this a inundation frequency graph. And essentially it gives you a picture of how much of the time is the wetland spending above certain levels. So if this line just ran along the normal water line, normal water level, that would tell you that it never went above or below that for most of its life. In this case, it's spending most of its time above normal water level, so you can see that's about 60%. So we can see it's spending 60% of its life well above the normal water level, and then it's staying above it for 80 or 85% of the time, and it hardly ever gets a chance to draw down below that and actually evaporate and dry out. You'll probably see in Thailand a more bimodal distribution of this, because you'll have it being really full in the wet season and dry in the dry season. But in Melbourne, this would be indicative of a wetland that's probably going to have plant failure, because it's holding the water level well above the water level, and it's doing it for most of its life. So that's telling us straight away that this wetland is going to have plant problems, and we need to go back and redesign the outlets, redesign the size of the wetland, redesign the water levels, whatever we need to do to try and get that line down closer to the normal water level. So, it runs along here, and then maybe it comes up at, over here somewhere. So this is really useful to look at when you're doing a design, and so the modelling tools we have allow us to generate these curves, and then we can have a look at it and see whether the wetlands are likely to have good conditions for supporting the plants or not, and then we can go back and tweak the design to try and improve the outcomes. So with a wetland this bad, you'd probably come back and say it needs to be bigger, probably undersized for its catchment. If that's not an option, the next thing might be that we look at bypassing some of the flow, so it's not getting so much water coming in as often as it is. Obviously that's a trade-off. Any water that comes in is treated, any water that's bypassed is not, but at least it's keeping the plants alive to treat the water that is coming in. And then we might play with the outlet so that we let the water out more quickly, so that it's not holding water for such a long period of time. Question?
I think Dale gave a very good overview on the wetland plant species selection in Australia, predominantly in Victoria. I think when we work on a real RD project in Thailand, it's down to what species do we choose. Right? It's because it's about how the plant can tolerate prolonged inundation. Yeah. Unless you have a flooding event up to more than 4 weeks, which rarely happen. Right? Even Hwaya, maybe only 2 or 3 weeks. Right? So I'm sure that there must be a lot of species that we can choose from to tolerate that type of inundation. Because at the end of the day, what's killing the plants is because of the prolonged inundation, reduce the gas exchange into the soil. That's the killing factor, right? And if we say if your inundation is about 3 or 4 weeks, maybe happen every 5 years, what you get is unhealthy plants, but it will recover. It will recover after flooding period. And let's say if your wetland is significantly undersized, as Dale talked about, what happens is that the initially selected species may not survive, but the natural selection process will take over. More species will come over because they can tolerate a different flood frequency curves. So it's not the end of the day, and there's many ways we can design around that.
Yeah. And as Jerry is saying, wetland is a dynamic ecosystem, so the plants will essentially they'll shift and they'll move and they'll grow into those areas that they can survive well in, as long as they're given opportunity to do that. It may mean that water levels need to be reduced for a period of time to allow time for juveniles to establish and to grow and to recover. And we talked about the costs of replanting before. One of the tricks that can be used, instead of just mass whole replanting a wetland where you've lost plants, one trick is to simply lower the water levels and keep them down for a period of time. And that can allow the plants and the seeds that are already there and in the soil to establish and expand and to grow. And that can sometimes, not always, but depends on the conditions, but it can be effective in re-establishing the plants within the wetland. And then as they get taller, then they'll tolerate those really wet conditions longer. The other approach, obviously different species, but the other approach is to use what we call submerged plants, which is essentially plants that are adapted to growing under the water, and we put them in the deep pools of the wetland. So one approach is to have just submerged plants growing in those really deep areas that are going to be deep all the time. So you can have those, and then they'll also still provide some treatment. So that's another approach that we can use. So coming back to Melbourne and recognising you might adjust this for Thailand, we have three different zones within a wetland. One is the very shallow zone, then a mid-range up to about 350 mil deep, and then from there out to the deeper areas. So the shallow ones we put in plants that can tolerate being a little bit wet but don't like being very deep, but can also probably in a lot of cases tolerate also drying out completely at times. Then we have a little bit deeper water where they can tolerate a bit more depth of water. They're a little bit bigger plant, but again they're used to being in that sort of wetting drying zone. And then we have the deep pools, which is the deeper water, and that's where we put the plants that either can grow quite tall or that are submerged plants, so that they're used to being in that much deeper water. And there's different species that will work within each of these. Some of them will work across zones. Obviously, some will prefer different zones. So in this deep zone, we have some species like Phragmites or Typha, which in Australia often considered weeds in our wetlands, but they'll develop very aggressively, and that they will grow in the deeper areas and they'll grow quite well. But they don't like being in overly shallow water because it's too shallow to give them support for their stems and that sort of thing. Okay. Flip side of that, so what I think about inundation and drawing the water down so the plants can survive, but in tension with that and contradicting that is this idea of detention time and residence time. So I said before that we're aiming for that 72 hours of residence time ideally, and I've suggested that we might actually lower that to something a bit lower in those tropical environments because otherwise the systems will start getting too big. So that's really getting a balancing act of how do we get the best treatment performance out of this, but then also make sure that we're getting a realistic size of wetland, we're getting plants that will survive. But in Melbourne, it's probably fair to say that achieving this target and then achieving the inundation frequency targets, they're in direct tension with each other, so you're trading one off against the other in a wetland design in Melbourne generally. So as I've mentioned a couple of times, we do a lot of modelling of these systems as we do the design of them to try and understand how they're likely to perform in terms of their pollutant load reductions, but also to understand their inundation frequency patterns and how they might behave over a period of time. So we're not just looking at one design storm event like you might with a flood model, but we're looking at how they might behave over a period of 10 years. And then we're looking at averages across that, and then we're looking at different behaviours within that extended period. And essentially what that's saying is that most of the pollutants that we have that come through the system are not because we had a 1 in 10 year storm that suddenly brought a whole heap of rain, but it's the frequent every other day storms that you get throughout your wet season that are bringing constant rain, washing pollutants through the system and bringing it through. So what we see is that most of the loads of nutrients, of sediment that come through the system are actually derived from these everyday storms, not from the very occasional. Obviously, if you get an occasional flood, it does do a lot of damage and a lot of stuff when it happens. So that's why we design for these everyday storms, and we use a long period of simulation modelling to represent that. That also allows us to start looking at these inundation patterns and the spells and the durations. How long has it been wet and keeping the water at a high level? If it's keeping there for 2 months, we've got a problem. How long has it been dry, and is it drying out completely in summer? So it allows us to have a look at these different things. So there's a model called MUSIC, Model for Urban Stormwater Improvement Conceptualisation, mouthful. It's been developed in Australia, and it's basically become the de facto standard for modelling wetlands and stormwater treatments in general in Australia. So you'll hear us mention it and talk about it. It's very widely used. Understand you're not necessarily looking to pick that up in Thailand at the moment. Probably the nearest alternative to it is the SWIM model. Does anyone use SWIM? EPA SWIM? Oh, yep. You've used it? Yep. Okay, a couple of you. Good. That's probably the nearest analogy. Basically, we feed into a climate template, so a rainfall time series. We feed into it evapotranspiration, and then we tell it about the wetland and all the parameters. and then it models the catchment runoff, and then it models the water passing through the wetland and tells us what the water patterns will be, and then it also models the pollutant generation from the catchment and how much pollutants are likely to be generated based on some statistical assumptions, not the actual pollutant concentrations at a particular point in time. And then that allows us to look at what the load reductions might be. And that gives us some results that look something like this, and it says these are your loads in, these are your loads out, and these are your reductions. And then because we've got standards here that say what percentage reductions we have to meet, we can then compare the results from our design and see whether we're meeting those objectives. And so a developer consultant will design their wetland, they'll do all the stuff we just talked about, they'll chuck it in music and they'll model it up, and then they'll fiddle around with the model and they'll adjust the design until they can get it to meet the targets that they've got to hit here. And then they'll submit that to the relevant authority, the council and Melbourne Water, and say, here's our wetland, here's the design, here's the modelling results, please give us approval for this wetland that we've designed and for our development so we can go ahead. So thinking beyond stormwater quality.
It's okay, we're gonna make some adjustments.
Okay,
Just
okay.
keep going.
Yep, just keep going?
Yeah.
I'll tell me when to pause and you've got
We'll do the lab tour tomorrow.
Yep.
Okay.
Oh, really?
Yeah,
Okay.
yeah.
Yep.
That's okay.
Okay. Yep. All right. So stormwater treatment is one part of wetlands, but it's not the only thing that a wetland can do. So we do want to think of wetlands as being multifunctional or multi-purpose assets. So besides stormwater treatment, obviously they can also provide a flood storage above the wetland, so you can have it in the detention basin and providing that dual function. We can also get a certain amount of habitat out of them. So there'll be a better biodiversity. We've got wetlands, they support all sorts of fish, frogs, insects, occasionally other mammals, you name it. So they're good for that. And then the other thing they're good for is landscape amenity. So the other thing that we've done in Melbourne, and I think one of the reasons why wetlands have been successful and adopted, is that developers have realised that not only do they have to build a wetland and it meets all their stormwater boxes, but if they get the design right, it becomes an asset for their development. And so what they do is they build a big park in the middle of the development, or at the bottom end ideally, that's where water's going to be going, and they have a large park there, and they put the wetland in that park, and they put paths around it, and they put some seating around it, and they make it all look really nice, and then they have some open water, and they always want lots of open water, which is hard when we're telling them that they're only allowed to have 20%, because they always want more than that. So they have some open water there. Sometimes they'll put a big lake downstream of it, so they get more open water, and then they'll make that a feature of the development, so that all the houses that are sitting around that park that are overlooking it, they can sell for a premium. And they can get more money selling those houses than all the other ones in the development, because they're overlooking the park, they're overlooking water, everyone loves being able to see a bit of water if they can, and they find that that actually helps. So it means that, well, they didn't want to give up that land for the wetland, they're not so really opposed to it, because at least they're getting something for it as well, and there's some benefits. But it then means that community, because the developer finishes their job and moves on, and they don't care what happens after that. The community moves in, and then the community can go down and enjoy that asset, and they can enjoy, you know, seeing the different creatures moving around it, and they can enjoy looking over the water and that sort of thing. So it actually becomes an asset for that community, if we do good design. I'll put that caveat there because it doesn't always happen. So we get those. Some people have got a bit more creative, and they've even looked at how they can do public art around them. You know, we've got little heads popping out here for kids to come and find, and you know, art installations of education with signage around the wetland telling people what it's for and how it works, so that it's providing an education piece as well and helping people understand the vision and understand why we're doing these things and what we're trying to achieve. You know, we want a healthy Port Phillip Bay, we want a healthy Yarra River, we want a healthy manual local waterway in this area. So it can provide these benefits. The other thing is that it's cleaning the water. And we've got all this clean stormwater coming out of the bottom of this wetland, and then it's just going to the environment and then discharged out to the bay, and we know that there's too much water, the environment doesn't really want all that water. So the other thing we can do is that we can actually take that water, and we can put it in a pond, we can harvest it, and we can use it to irrigate the sports fields or the parks around that wetland. So we can actually get the water and use it for a beneficial purpose as well. And this is Royal Park, which must be close to 20 years old now, maybe not quite, that is operating as a stormwater treatment and harvesting scheme, and is functioning quite well. This is one of the largest parks in the city. But we're doing this increasingly now, and the reason is that we went through 15 years of drought in Melbourne, and during that drought we had a rule that said you're not allowed to irrigate your parks, you're not allowed to irrigate your open space, you're not allowed to irrigate anything. I think the council's got a concession so they could irrigate 1 sports oval out of 4. So think what that does to your sports teams if you can't water the sports fields and the ovals during the dry season. You know, those fields are dead. You know, we were getting no rain in some years, very little, and it meant that it decimated all the sporting clubs. And so some of those councils said, all right, we're not going to take that chance again. Let's build stormwater harvesting schemes so that we can get at least some water to all our parks and reduce the load on the potable system. So 1, we've got a guaranteed supply, we know we'll get some stormwater, but 2, we're taking the pressure off the potable system so that we've got more water available for other purposes and to then water those parks when we really need it. I will put a caveat, it is an expensive way of getting water. So it's good, but it is costly. So I'll put a caveat on that. So get the design right, we can make these systems look really nice, we can get people down to come and see them. We can put public art installations around them to really get people to engage with the wetland if we want. So there's all sorts of things we can do to be a bit more creative. It doesn't just have to be concrete box. This is Docklands, so again, JB and I worked with Tony Wong and Peter Breen for many years. They designed this one as well. And again, it was a pretty successful combination of some public art and a wetland together. I took my kids and we rode under this a few weeks ago, so they loved it. But if you have to, because you haven't always got, I'm showing you these beautiful open spaces, and some of you are probably thinking that we don't have that much space in Bangkok. It's built up, it's urban. We don't have that space. So there is hope, because you can get wetlands into really high built-up areas. It's harder and it's more challenging, but you can put them into these built-up areas. So this is a couple from China where they've incorporated it into some of the larger spaces they've got, but also into some of the plazas. So you can put them in quite challenging environments. So I think we covered this because we talked about operational maintenance before. Let me see what I missed and we'll recap on a couple of key points. So the main things you'll do is you'll clean out the sediment at the front end, but also remove any blockages at the inlet and outlet. And it's really important to make sure that the outlet in particular is not blocked and it's working well, because the fastest way to kill a wetland is to get a good plastic bag wrapped around the outlet pipe, block it up, or a bottle or something jammed in it, blocks it up completely, the water can't get out, and then the wetland fills up and then all the plants die. So we've always got to make sure we're checking the outlet on these things. Melbourne Water have got to the point where they're starting to put level sensors in their bigger wetlands. So if it does fill up and it gets blocked, that they actually get an alert and a warning so they can go and make sure it's unblocked. You think about it, you don't want to find out 3 weeks later that the wetland's full and you've lost $200,000 worth of plants and you've got to go and reset it. So it's big money for some of these big wetlands we've got. So that's key thing. Need to come in and replant veg. It's ideal to remove any weeds as soon as we can so that they don't just keep spreading and getting further. Fill in any gaps so that the weeds don't get to grow. The other thing there is that if you get any scouring and erosion in the wetland, that tends to just keep growing and expanding if you just leave it. So if there's any scour, then we come in and stop that, replant, put some coir logs or other erosion control features in just to stop that from expanding and re-establish the soil in that area. And the other thing that's commonly done these days is that we'll actually control the water levels and bring them down to let the plants re-establish.
Do you need to cut the tree?
Do we need to cut the plants?
Yeah.
Good question. We got asked that a lot in the early days. We don't, as general practice, cut the plants anymore. The plants will naturally, they'll die off and they'll sink to the bottom and get tied up in the sediments or break down and they'll grow again. So as general practice, we don't go and harvest the plants.
But if you need a good landscape, something like that, if you don't cut the tree, it will be a forest in the future, something like that. And maybe the young people come to this area, something like that.
So we don't generally do too much pruning of the plants in the wetland itself, but the plants around the wetland, absolutely. If you've got trees around it, you can maintain them and trim them. The other thing I'd say is try and make sure that the trimmings, especially the grass cuttings, make sure you don't put them in the wetland. Make sure they get taken away.
And who responsibility to maintain the plant around the wetland?
Yeah. So your arrangements may be different. Melbourne Water generally are responsible for the water surface area. And for the immediate batter planting, the wetted, like the area that will get wet and dry out, that immediate batter planting around the wetland, that would be Melbourne Water's responsibility in Melbourne. For the park and the surrounds around that, usually it's the local council that's responsible. So they'll trim the trees and they'll mow the grass and that sort of thing. Often there'll be a mowing line and they'll mow everything up to the mowing line. And then everything beyond that, Melbourne Water will be responsible for the higher vegetation beyond that. But honestly, you do need to come, like you'll have trees in the butters, you do need to come and maintain and trim them and look after them. Just, it's the same as any landscape. So,
earlier, this one is the pool, the sediment pool, but for the wetland area, looks like we have to replant every 3 to 5 years.
Yes.
Every 3 to 5 years.
The wetland area.
Yeah.
You have to.
You shouldn't need to replant it that often. If your plants are growing well, they should continue to grow and senesce and die off and grow again.
Absolutely.
Like for 20 years or for.
Yeah, we're working on 20 to 25 years, but if you get the design right, they'll last longer. We find probably 1 in every 4 or 5 wetlands won't be designed well, and it'll be falling apart within 3 years or 5 years. But that's the exception, not the norm. The well-designed ones should last much longer, and you shouldn't have to come and redo the plants all the time. That said, when you first start, you'll make lots of mistakes, and you'll have to go in and do a bit of work on the first few you do. Don't be upset if that happens, because it will. We're still figuring it out 25 years later, getting them all just right. So, but like Royal Park I showed you, was it a couple of slides ago? Yeah. This one here, that's more than 20 years old. To my knowledge, that's never been replanted. It's got a few bare patches, could do with a bit of work, but it's growing fine, it's doing perfectly well. So,
do you have weed, like the weed or plants that you don't want, but it will?
Yeah. So the main challenge is to get good plant coverage. Once you've got good plant coverage, it keeps the weeds out because there's nowhere for them to grow. If you've got a poorly established wetland, then that lets the weeds in, and once they get in, they'll continue to expand, so they need attention. The biggest challenge we have in Victoria is typha, which is a really large, aggressive growing plant. And it grows naturally in the waterways, but once it gets into a wetland, it'll just slowly expand and take over all the deep areas because it's quite strong and grows quite aggressively. We don't really look, it's a plant and it'll work as a plant and it'll still do stormwater treatment. We don't really like it because it tends to block things up and not let the flow pass through evenly, but it also crowds out any other vegetation, so we'll tend to come in and remove it if we get typha in there so that other plants can grow and establish. But once you've got good plant cover, that's usually effective in keeping the typha out.
Because in Thailand now, for the ID, we have the fund from the GCF to construction the like EBA, same NBS, in the Phitsanulok province. And this area is responsibility by the operation and maintenance project in that area. And our staff said, when finish the construction, we let possibility to cut the tree. Because now, like you explained in the morning, our canal now some part is like earth canal, and the farmer come to explain ID. Why you don't cut the grass, something like that? It have a problem with the water is slow, not quick that they want to go to the farm. The farmer come to ask me, you must clear the canal, something like that. And but in the future, if we put the NBS light in the morning in the canal, and the farmer don't understand the concept, they said, what do you do? ID it's very dirty. So maybe tree something like that. It's really hard to explain them because they want the water come to them quick that they need something like that.
They want the water to move through the canal and come to their farm, you mean?
Yeah.
I think there's it's about how we communicate, explain to the community. But I think the key thing is we are not trying to overhaul the entire system overnight. Let's say if you have a irrigation canal, that's your main canal, and then you have sideways, right? Distribution lines, right? I think that I don't know whether your EDA project where it's going is not trying to convert all of this into the ecological, repairing, meandering pathway. Is find a section and convert that into an RD park. Let's just say become RD park. Immediately people find, okay, I have a three-sided concrete channels. Suddenly I have an oasis. Okay, who benefits? These people benefit from this. Right? They can set up a cafes or a house look much better than houses here. And then people realize, okay, you have wetland here, you have oasis, you have urban forests, you have swamps. Then people realize the difference between this section and that section. And people say, why didn't you build an RD farm in front of my house? You turned that land around, right? That's how you engage with the community. Sorry.
That's right.
That's good. That's one of the strategies.
I think if the people see the benefit that they can get, it's no problem to explain. But for the start, because this is like a new concept for the farmer. And what do you want to do? Something like that.
And they haven't seen it before.
It's really hard to not only farmer. My boss also. He comes after we back from the Australia and we create some like NBS some part. What do you do? What is the benefit? Something like that. It's hard to explain.
Yes. And that's why I think it's important to not only understand the infrastructure and the technical aspects, but also to actually begin to think about what your positive benefits are going to be. What are the really good things that can happen by doing that? So when your boss says, but why are we spending money on doing this? You say, well, number one, number two, all of those kinds of things,
Just borrow Helen's slides.
And I think even if we begin to look at the wetlands from the point of view of people with a disability, which is invisible, okay, so maybe it's a cognitive or a mental disability. We now have health research that has been done because of COVID, and Melbourne was shut down for almost 2 years because of COVID. The health benefits of leaving your house and going to walk in a park or in a wetland or along the beach or in a botanical garden, those health benefits for mental health are very, very high. Now, we're just beginning to get that research because COVID was a bad situation that has actually created the need for that research. But the research is incontrovertible that you get more people outside walking in nature where there's water. That's why people pay so much money for a house that looks over a lake or a river, that you actually get really, really good mental health benefits from it. So you can start to see how even JEDC can begin to, not just community engagement, but you can see how all of these things, and so that's why we need to think about it and have those arguments at your fingertips when you're dealing with people who maybe don't understand.
Yeah.
Thank you.
And another thing, our problem now is for the budget. Because the budget for the government it relates with the duty of the department. If we say that this NBS is like treat the water, something like that, or the domestic use, something like that, is the budget value said this is not your duty, and you can't get the budget. And because if ID want to do this project, we must considering first priority is for farmer, for flood or for drought. But in that time that I mentioned before at the Pisanuro, our consultant said the benefit you can get more fish, something like that. You can get the part for the relays. And when I put the proposal to get the budget, it's not your duty. It's another department. It's very hard to. This is just only our problem about the way to get the budget.
I think Jianbin said in the first presentation that when you go home, you are going to be champions for nature-based solutions. You're going to be the leaders in this area. And because I've been working in JEDC for so many decades, I know that you cannot get an idea over the line the first time. You will talk to people and they'll say, oh, we're not going to do that. Or you'll talk to someone and there's no budget for it, or it's not your responsibility. But you just keep trying. You just keep pushing.
Again and again.
And again. and even in the design of wetlands, in leadership studies, we have in English a term which is FAIL, F-A-I-L. And generally in English that means that you have not been successful. But in leadership studies, we just say that is the first attempt in learning. So you design wetlands, you do it, you learn from it. You do an iteration, as the Chinese do. You design it better the second time until you actually get it. It's 90% operational. And it's the same with the kind of work that you'll be doing as leaders. You may not be successful the first time, but you just keep pushing.
a little.
We need an example, okay, so one of the projects that we're working on, just with one household so far, in Luang Prabang, I mean, you can't just go into a community and build what Janbin showed you, that wetland that was in pipes. We worked with an NGO that had been working in that community to help to raise awareness on why to keep these ponds, why it was important. Because frankly, for a lot of people, easier just to fill in the pond, sell the land, build a nice hotel, go live outside of Luang Prabang, right? So, but then, this NGO has been working there for 5, 6, 7 years, and they've done so much work within the community and to raise awareness on the importance of the ponds, working also with the government to help the community retain and sustain those ponds. So it frankly it was a good environment to go in and say, hey, we're going to try this approach, which will help improve the water quality that is coming out of your house, and eventually will improve the water quality of the pond. So I think it's also about finding the right opportunity, people with maybe open mindsets, or collaborating with a group or a community that is willing to do this as the first step.
It's I understand what Dr. Honoko said, because NGO sell the idea to local community, that's fine, but government agency is born with the mission and vision, and the mission of each agency is different. The mission to create wetland, aesthetic, I don't know.
So everyone has their own.
Yes, and so we cannot ask for the budget that belong to other agencies' mission.
Can I jump in? So water agencies in Thailand is very fragmented. There's 3 main departments overlooking water across Thailand. Already is one of them. But what I maybe want to share is that one of RID's main objectives is to manage flood and to ensure water security. Constructed wetland can help with that. So
We have to link to that.
constructed wetland provides multifaceted benefits. So it provides 2 of these benefits that fits in your department's main objective. There are other benefits on treatment or improving quality of life. It fits in other departments' objectives, yes. But that is also a good opportunity for you to maybe have a joint project with maybe PCD or those other departments that works on in that regard.
And those department is in different ministry. This makes it even.
After 3 years engagement with Thailand, what I learned is that the strategy to engage, like say DPT, right, in the rural municipality is that RIB has to do an excellent job in building one project. So that DPT they are afraid because they may not be able to compare or compete. And then what they say, they'll come to RIB and say, okay, here's our budget. Can you do it in one go for us? That's how we work together.
This is why I asked Mr. Joe to shoot the important pilot project. But if you can show this is relate with our duty, our department, it will continue. But it separate. This is not our duty. It's another department. It will stop. This is why I suggest that Chiang Rai province, if you can contact like now we have a problem about the international river. It's from the Myanmar, and they have a mine, gold mine, and they have aอะไรนะสารหนู heavy metal, arsenic, yes, along this river, and ID have the weir to divert the water to the canal for the farmer, and now the farmer ask the ID, I can crop the paddy or not? The quality is good, and if I crop, I can sell because the people come to buy not much. This is safe or not? If we can like wetland in the side of our canal and bypass the water that contaminate to the wetland and can reduce the arsenic. My boss is okay. Do it.